Hello, in this video I will defend report to model 16 and 17. First, model titled Network Security Fundamentals, the topic title Security Threats and Vulnerabilities, network attacks, network attack mitigations, and last, device security. First of all, security threats and the vulnerabilities. First of all, it's types of threats. Wired and wireless computer networks are essential to everyday activities. Individuals and organizations depend on their computers and networks. Intrusion by an unauthorized person can result in costly network outages and loss of work. Attacks on network can be devastating and can result in a loss of time and money due to damage or theft of important information or assets. There we see the quiz and checking my understanding about security threats and vulnerabilities. Then the second topic, network attacks. First of all, types of malware. We have general two types of malwares. It's viruses, worms, and Trojan horses. First of all, viruses. It's a computer virus is a type of malware that propagates by inserting a copy of itself into and becoming part of another program. It spreads from one computer to another, leaving the infection as it travels. Viruses can range in severity from causing merely annoying effects to damaging data or software and causing denial of service. It's like DOS conditions. We also have DOS attacks. We will consider in the next topics. The second worms. Computer worms are similar to viruses in that they duplicate functional copies of themselves and can cause the same type of damage. In contrast to viruses, which require the spreading of an infected host file, worms and standalone software and don't require a host program or human help to propagate. In the last, Trojan horses. The Trojan horse is another type of malware named after the wooden horse and Greeks used to infiltrate Troy. It's a harmful piece of software that looks legitimate. Then we see the quiz that checks my understanding about network attacks. First of all, denial of service DOS attack, then access attack, malware attacks. Malware attacks include viruses, worms, Trojan. There's two questions about that. In this last denial of service attack, it successfully prevents unauthorized users from accessing system resources. In a reconnaissance attack, the threat actor can probe a system to find what ports are open and what services are running. Then we see the lab work, research network security threats. Lab work named as research network security threats objectives. First part about to explore the SANS website, part 2 identify the recent network security threats, and part 3 detail a specific network security threat. And there is we see the background of scenario, then the required resources, and then. Next, it's network attack mitigations. First of all, it's defense in-depth approach. To mitigate network attacks, we must first secure the devices, including routers, switches, services, and hosts. Most organizations employ a defense in-depth approach, also known as a layered approach, to security. This requires the combination of networking devices and services working in tandem. Then consider the network in the figure. There are several security devices and services that have been implemented to protect its users and assets against TCP/IP threats. Then the second step, like keep backups. Backupping of the device configurations and data is one of the most effective ways to protecting against data loss. First of all, if there is was a virus that clean of all your data, you if you have a backups, you can uh, s- uh, how to say, save your data, and there is we have a table that considerations of their descriptions. Um, there is consideration, description, its frequency, validation, and so on. And the next step: upgrade, update, and patch. Uh, I- why we must should do these steps? It's like if we also update our system, for example Windows. Uh, in new systems we have new more strong antivirus. It's or something like that. And the next, authentication, authorization, and accounting. All network devices should be securely configured to provide only authorized individuals with access. Authentication, authorization, and accounting. It's triple A. Network security services provide the primary framework to set up access control on network devices. We also have a concept of triple A similar to the user credit card. There is code of authentication, we have CVC code, um, then firewalls, it's like antivirus, but in the servers. A firewall is one of the most effective security tools available for protecting users from external threats. A firewall protects computers and networks by preventing undesirable traffic from entering internal networks. There is we have types of firewalls. Firewall products can be packaged in the various forms. There's the products use different techniques for determining what will be permitted or denied access to a network. First of all, packet filtering prevents or allows access based on IP or MAC addresses. Then application filtering prevents or allows access by specific application types based on port numbers. Then URL filtering prevents or allows access to websites based on specific URLs or keywords. Then the last stage for packet inspection, SPI, incoming packets must be legitimate responses to requests from internal hosts. Then unsolicited packets are blocked unless permitted specifically. SPI can also include the capability to recognize and filter out specific types of attacks such as denial or service DOs. Then endpoint security, it's like secure the links of our server. An endpoint or host is individual computer system or device that acts as a network client. Common endpoints are laptops, desktops, servers, smartphones, and tablets. Securing endpoint devices is one of the most challenging jobs of a network administrator because it involves human nature. A company must have well-documented policies in place, and the employee must be aware of these rules. Then checking the understanding network attack mitigation, there is we have 5 questions. Then next, it's device security. Uh, there is first of all we have Cisco Auto Secure that automatically secure our smartphone, tablet. Uh, Also, we can configure it with terminal. Then then passwords to protect a network device. It's important to use strong passwords. Here are standard guidelines to follow. First of all, it's use a password length at least 8 characters, preferably 10 or more characters. A longer password is a more secure password. And make passwords complex, like include a mix of uppercase, lowercase letters, numbers, symbols, and spaces. It's if allowed. Then avoid password based on repetition, like 1 2 3 4, or 1 1 1 1 2 2 2 2. Then common dictionary words, letter or number sequences like 1 2 3 4. Then usernames like your name or your username in the, for example, game. then relative or pet names, your pet names, and so on, so on. Then the second or the next deliberately misspelled password. For example, Smith, 5MYTH, or security like 5ECUR1TY. Then change passwords often, like one times per month. Then don't write the passwords down and leave them in obvious places such as on the desk or monitor. We have a table of the weak passwords in the determination why it's weak. Then additional password security. Strong passwords are only useful if they are secret. There are several steps that can be taken to help ensure the passwords remain secret on Cisco router and switch. Include these: encryption all plain text passwords, setting a minimum acceptable password length, and so on, so on. Then enable SSH, it's secure shell. First of all, step 1, configure the unique device hostname. Step 2, configure the IP domain name. Step 3, generate a key to encrypt SSH traffic. Step 4, verify or create a local database entry. Step 5, authenticate against the local database. Then disable the unused services. Uh, Then there is a packet tracer to configure secure passwords and secure our shell. We see the scenario. The network administrator has asked you to prepare RTA and SV1 for deployment before they can be connected to the network. Security measures must be enabled. We have the steps, explanation, and how to do that. With time and what percent we complete. We configured our SS secure shell uh, in terminal desktop. Then we see the step 2, configure basic security on the switch. Then steps how to do that. And there is ipconfig. Then information about our LTA, PCA, SU1. Then log work to configure network devices with secure shell. Objectives: Part 1, to configure basic device settings. Part 2, configure the router for secure shell access. Part 3, configure the switch for secure shell access. Then Part 4, secure shell from the CLI on the switch. Then we see the scenario. Then there is the packet tracer to secure network devices. Then we see the steps. First step, decrypt the network. Then step router configuration requirements. Here is also see same. Then we see step 3 and percent of the completion. Step 3, switch configuration requirements. Uh, then what we learn in this model. First of all, security threats and vulnerabilities. Then network attacks, network attack migrations. Then securing the secure network devices, secure shell, and so on, so on. The last model quiz, network security fundamentals. The next, the finding report to model 17. It's also assignment 8. And what we learn in this model: first of all, devices in a small network. Then it's to identify the device used in small network. Then small network application protocol scale to larger networks, verify connectivity, host and iOS commands, troubleshooting methodologies, troubleshooting scenarios. First of all, small network topologies. The majority of business are small, therefore it's not surprising that majority of business networks are also small. A small network design is usually simple. The number of type of devices included are significantly reduced compared to that of a larger network. For instance, there were the sample small business network shown in this figure. Then we see the IP addressing for a small network and how it works. There is a topology of small medium-sized organization in the figure. The redundancy in a small network. Important part of network design is reliability. Even small business often rely heavy on their network for business operation. A failure on the network can be very costly. There are many ways to accomplish redundancy in a network. Redundancy can be accomplished by installing duplicate equipment, but it can also be accomplished by supplying duplicate network links for critical areas as shown in the figure. Then traffic management. The goal for a good network design, even for a small network, is to enhance the productivity of the employees and minimize network downtime. The network administrator should consider various types of traffic and their treatment in the network design, and the router and switches in a small network should be configured to support real-time traffic such as voice and video in an appropriate manner. Relative to other data traffic, in fact, a good network design will implement quality of service (QoS) to classify the traffic carefully according to the priority during times in congestion. As shown in the figure, it's first, and we have a video, the last part, traffic sent to breakpoint in order to priority, it's high priority. Then we see the quiz, checking my understanding about devices in a small network. Then there is common protocols. Most of technician work in either a small or a large network will in some way be involved with the network protocols. Network protocols support the application and services used by employees in a small network. Network administrators commonly require access to network devices and services. The two most common remote access solutions are Telnet and Secure Shell. Secure Shell service is a secure alternative to Telnet, who connected administrators can access the Secure Shell server devices through they were logged in locally. We see the network devices and the server. There is uh, network application are software programs used to communicate over the network. Some end-user applications are network aware, meaning that they implement application layer protocols and are able to communicate directly with the lower layer of the protocol stack. Email clients and the web browsers are examples of this type of application. Then application of layer service, it's other programs may need the assistance of application layer services to use network resources like file transfer or network prints pooling. The voice and video applications business today are increasingly using IP telephony and streaming media to communicate with customers and business partners. Many organizations are enabling their employees to work remotely. As the figure shown, many of their users still require access to corporate software and files as well as support for voice and video applications. In this figure we see video message, we see telephony, then uh, text texting, then there is a checking understanding about this part as monitor application protocols. Then scale to larger networks. How will our small network scale to large network? What requirements? So required. First of all, it's network documentation. Then device inventory, budget, money. Then traffic analysis. Protocol analysis. As the network grows, it becomes important to determine how to manage network traffic. It's important to understand the type of traffic that is crossing the network as well as the current traffic flow. There are several network management tools that can be used for the purpose. However, a simple protocol analyzer such as Wireshark can also be used. The verify connectivity with ping. We also can verify it uh, with with what? With what? I forgot. Okay. verify connectivity with ping. The ping command is most effective way to quickly test layer 3 connectivity between the source and destination IP address. The command also displays a various round-trip time statistics. Specifically, the ping command uses the Internet Control Message Protocol (ICMP) error request ICMP type 8 and error reply ICMP type 0 messages. The ping command is available in most operating systems, including Windows, Linux, macOS, and Cisco iOS. The extended ping standard ping uses the IP address of the interface closest to the destination network as the source of the ping. The source IP address of the ping 10.1.1.10 command R1 would be that of the G000 interface, as illustrated in the example. As we see PK1, PKP, then we can connectivity verify it with traceroute. The ping command is useful to quickly determine if there is a layer 3 connectivity problem. However, it doesn't identify where the problem is located along the path. Traceroute can help locate layer 3 problem areas in a network. A trace returns a list of hops as a packet is routed through a network. It could be used to identify the point along the path where the problem can be found. There we see the syntax of the trace command varies between operating systems. It's Windows, the Cisco iOS trace commands. Then IP configuration on the Windows host. If you mm, uh, and found that some part of your network is not working as it should, now is the time to use some commands to troubleshoot your devices. Host and iOS commands can help you determine if the problem is the IP addressing of your devices, which is common network problem. Checking the IP addressing on the host devices is a common practice in networking for verifying and troubleshooting end-to-end connectivity. In Windows 10, you can access IP address details from the network and sharing center, as shown in the figure, to quickly view the four important settings: address, mask, router, and DNS. IP configuration on a Linux host. Verifying IP address using the GUI on a Linux machine will differ depending on the Linux distribution, distro, and desktop interface. The figure shows the connection information dialog box on the Ubuntu distro running the GNOME desktop, then configuration on a Mac OS host, the GUI of a Mac host. Open Network Preferences Advanced to get the IP addressing information as shown in the figure. As we see the TCP IP, then configuring IP version 4, then configuring IP version 6. There is DHCP, subnet mask, router, IP address, then troubleshooting methodologies. In the previous two topics, we learned about some utilities and commands that we can use to help identify the problem areas in our network. There are many ways to troubleshooting a network problem. This topic details a structured troubleshooting process that can help us to become a better network administrator. It also provides a few more commands to help you resolve problems. Then debug command. All debug commands are entered in the privileged exec mode. The Cisco iOS allows for narrowing the output of the bug to include only the relevant feature or sub-feature. Uh, the terminal monitor command. Connections to grant access to iOS command line interface can be established in the following two ways: locally and then remotely. There is we see checking, understanding, then duplex or operation and mismatch issues. There is two type of duplex communication modes: half duplex, duplex, and full duplex. and the IP addressing issues on the iOS devices. Uh, iOS devices, we use show IP interface or show IP interface prior commands to verify what IP version 4 address are assigned on the network interfaces. Then, what we learn in this model? First of all, devices in a small network, then small network applications and protocols. Also, we learn about small networks and how to scale these networks and what required. Then we see the model quiz about building a small network. And this is hello.